Okay, so this is Adam's Aquaponic Automaton. It's a bit of a nuts project. This video is just a little bit of an overview. There we go, it's doing stuff already. This is a bit of an overview of what's going on here. There are three main tanks. F is for fish tank. Beneath that is S, that's the sump, and on the left hand side you've got G, that's the grow bed. There's some little plants there. You'll forgive my filming. I am doing a web development degree, would you believe it? Not a film. Anyway, so in this sump, this is where I suppose all the water drains to. This is the lowest point in the system. In this sump we have, see if I can get a bit closer, we have a little pump that is working to raise the water up to the fish tank. Now, as you've already seen, the lights and all the stuff keeps on going on and off at the moment. That's because I've got it set up to turn on and off with the water sensor I've got here. And this is not actually how the system works, but it just demonstrates that all the components do actually work. Whether or not they automate the system or not, it's a different story, but hey hey. Anyway, so in this fish tank we have two components. We have the one wire sensor and the heater, and as you can see the little orange light is on, so that's set to heat. Over here on the right hand side I've used the flow sensor to measure how much water I was putting in when I was actually filling the fish tank up. So there, on one of the fills it was 9.38 litres and the other it was 9.5. I suppose another interesting point to point out on that is, I was talking about the flow sensors, that's the flow sensor over there. It comes in through a regular sort of garden hose. So once the water is pumped up in here, it's trickled out through these various holes. This is to aerate the water. Fish like really highly aerated water. It would probably be better to have a, you can actually get proper bubble machines for your fish tank. So when the water is pumped up into this fish tank, over here, if we can avoid the over here is an overflow valve. Now this is connected through a bulkhead, and so any excess water that comes in here will get drained off through the system, and eventually it will end up in the grow area. Now in this grow area we have, as you can see, the water is coming out these other little holes. Now normally this grow area would be filled with a substance like perlite or sort of clay soil. It needs to be basically as inert as possible. You don't want any added nutrients coming from substances that you use in here, so the idea is to use something that's pretty clean. These will eventually be about sort of take up the whole depth of this grow bed. It's about 20 centimeters deep there, and the plants will then grow on top. Now once the water has passed through the system and the plants have had what they need, the remaining water goes through this pipe and ends up back in the sump, where the process can begin again. Now in this grow bed we've got a couple of extra little things that we need to look at. Here we've got a little heater. You can hear the whir in the background. It's actually pretty noisy, and it's not been an ideal choice, but it does heat it up, and I've managed to get a reading, but automating the whole thing has been a little bit of a problem. We also have a little fan up here, and as you can see it's all contained in this plastic sheeting. If I come back, Now normally this plastic sheeting's down, so it would actually contain the airing. In one of the tests that I've done, I've shown that actually the air temperature inside this grow area is a little bit higher. It might be a difference in the temperature sensors, but they're actually pretty accurate. Now also the other key component of this is if I can make a bit more space, the LED grow lights. Now we've got a few bars that aren't working there. And they've decided to go kapunk. Anyway, so these LED lights are red and blue LED grow lights. The research I've done found that these different colours were actually better for photosynthesis, and they used the actual light range. Now in the centre of the screen there is the DHT22 sensor. Now this is a sensor that's meant to control both the heater and the fan to maintain the temperature, but I've been having issues trying to repeatedly poll this sensor to get updated feedback. So up until now it's not really managed to be automated, although I have got all the things running, but there's more work to be done here. Now the one area that I had managed to automate, as the document pointed out, was maintaining water temperature. And this is actually really important for the system. You're trying to balance 3 different organisms, so fish, bacteria and plants. So you need to have sort of a good environment for all those to exist, and using the heater and the one-wire temperature sensor, I've managed to control the water temperature in the system. Anyway, so let's have a look a little bit at the electronics up here. I suppose at the heart of it is this bad boy. This is the sort of power source for everything. It is a ATX 350 watt computer power source. They're pretty common and relatively cheap. I think this is about 20 bucks. Sorry, I'm not American. 20 quid. Yeah, there we go. Anyway, so from this I've managed to take sort of various different power supplies, so 5 volt, 12 volt and 3.3 volt, which has been quite useful, as all these sort of sensors and everything seems to work off different voltages. So at the heart of it really is the Raspberry Pi and Arduino. These two communicate via I2C. So the Raspberry Pi will send messages to the Arduino to tell it what to control. The Raspberry Pi also allows for sort of more data logging and things like this, which is slightly easier through the Raspberry Pi. It's kind of set up for that, whereas the Arduino is very much about its input-output capabilities. Now, as you see here, I have an Arduino Mega. I did start this with an Arduino Duo, however I blew it up, and I thought, well, bugger it, I'll just get a bigger one. Bigger is better. Anyway, so over here, this is what the Arduino is going to be eventually controlling, is all the plants really. Now over here we have, if I get it in focus, is the relay board. Now this is a 4-way relay that controls the fan and the heater. Over here you can see we've got fan and heater. These are little terminal plugs that I've covered up with electrical tape. I don't know what these ones are. Let's have a look. That one's for the moisture sensor, and that one's for something else. Anyway, they all do something. We've got the temperature and humidity sensor there. That's the DHT22. Anyway, so this relay board controls both the fan and the heater, as we've seen down in the grow area. Up here we have the solid state relays. These are 2 solid state relays that drive the lighting system. So as you can see, they've just been turned off. Now over here we have the power supplies for the pump and the heater. As you can see, they're just cycling through as well. These again are solid state drives. Now over here we have some useful tools. Also, this little bad boy is getting focused. Is the Barrow 100s. Sorry, BMP 100. This is a pressure sensor, so you can detect altitude if you want to, but it's mainly temperature and pressure that I'm looking for. Anyway, so down over here I've got a little breadboard. Some of the stuff isn't hooked up just yet, and I've been having issues when I've been trying to hook it up later, so